Awesome. Thank you, Sydney. Good. Well, it's an absolute delight to be here with you all today. Jason Mars. I'm a professor of computer science and engineering at University of Michigan. I'm also an entrepreneur. I'm an author. I wrote a book. It's an Amazon bestseller called Breaking Bots. It's about bringing conversational AI technology to market at scale, and it gives you that whole journey. Very excited to talk today about the future of conversational AI and how it hangs on one of our greatest fears. So I'm going to jump right in. Actually, there's a lot for us to cover today. So we'll be going on a journey. We're going to talk about why this is happening now. Why are we here where we are right now? Everyone's talking about AI. Everyone's talking about the conversational experiences to technology. And this all happened in the blink of an eye. So we're going to talk about that. Then we're going to talk about what exactly is AI and actually what's going on inside of these systems, right? There's so much talk about it, but very few really understand what it is, and we'll learn that today. We're also going to talk about where is it going? Where is it going in the next 4 years, the next 5 years? And so let's jump in to how we got here. Awesome. So this is where we are. Where are we now? If you look on the right side of this slide, you'll see a list of the top companies in the world, right? This is market capitalization. This is in the world economic markets, all of the companies. And what you'll notice is the majority of the top 11 companies in the world globally are technology companies, right? We got Apple, number one, with almost 3 trillion market capitalization. We got Microsoft, number 2, Alphabet / Google, all 2 trillion market capitalization. Amazon, Tesla, Meta, TSMC, that's the company that fabs the chips. Pretty much all chips that are not Intel, by and large, are created at TSMC. NVIDIA is number 10 at market cap at 600 billion, etc. Tencent. These are tech companies, right? And that's running our world economy right now. If you look at the ones that are not tech companies, you got Saudi Arabia's oil empire. You got Berkshire Hathaway at 700 billion. That's Warren Buffett's basically his piggy bank. You got Visa and then healthcare companies as representing the top companies in the world. But if you notice, it's dominated by technologies. And as we're going to talk about, all of these companies, these tech companies, are describing themselves, redefining themselves as AI companies right now. And this just happened. And let's see what I mean by this just happened. So we're going to go on a journey. I'm going to describe what a blink of an eye looks like. The world economy, our industry, the way that we live and work has changed in a blink of an eye. So we're going to look at what that journey looks like. We started with personal computers, then the internet. Something very interesting happened with making web search, social, and commerce happening. There's an eye of a storm there, an experiment, and then the AI revolution. I'd argue this experiment is inevitable. We'll talk about it, but it's inevitable because it's the deep ambition of the human condition, the human species. So personal computers, circa 1980. This is the first time we actually had computers. In 1980 is when the first computers came to the fore. Apple II, 1977, and IBM PC, 1981. Before this, we had landlines, and that's actually how we were connected. And so something super interesting happened just a few years later. Then we had the internet, right? Remember there was this .com, .bomb? Just within that 19 years from the monetization, the launching of the PC as a concept, we essentially had an early excitement around the promise of the internet. Now it bombed, right? And this is in 1999. It bombed, and it bombed because the market was early, right? Venture capitalists recognized the potential the internet had to change the world, but it ready. So we had a bomb before things came back. And I would argue it wasn't ready because it needed this next epoch of revolution, right? This is when in 2004, Facebook launched. Remember before Facebook, there was MySpace. It was all just a peculiar thing. 2004, Facebook launches. 2005, that's when Google really figures out how to organize the internet, monetize that, right? And so the internet wasn't useful during .com, .bomb, useful enough for the world because it was difficult to access information. And this is the same year, 2005, that Amazon tore out, right? So we had the PC in 1980, and just 2 decades later, we figured out how to organize the internet and make it useful. And Facebook launches the same year. Now, this is when we had the perfect storm, right? The perfect storm is advancement in data. We're producing data at an exponential rate at this point. I mean, this is the point where everyone's online. People are using it for social. This is the terraforming of the way we interact with our fellow neighbors in the world is happening here. So we're producing incredible amounts of data. The processing got really, right? We have supercomputers in our pocket around this time. This is when the smartphone came to the fore. Right around 2004 is when everybody on the planet had a smartphone. And then we have advancement in models, right? Deep learning gets dusted off, and the simultaneous availability of data, availability of processing, and the deep learning models launched us into the experiments, right? And this is the beginnings of the AI revolution. In 2010, Google launched Imagenet, right? And some folks may not remember this, but Google launched this experiment where they applied for the first time deep to encyclopedic computer vision, right? An AI that can recognize what is in pictures. And they had people on the internet label, right? That's one of the challenges, is getting labeled data. So Google launches this project, and it changes the outlook for deep learning. And it educates the market that there's a new way we should be thinking about artificial intelligence. We should be utilizing the copious amounts of data and processing to be able to take AI to the next generation. At the same time, same year, Apple launches Siri, right? And Siri, everyone knows what Siri is. It's the first conversational AI. And so the market appetite was whetted at this particular year. And this is the year that started an expectation that we would see AI in our experiences and AI in our products, right? And it actually, the science changed with this innovation. Thank you, Google, for Imagenet and nudging us to understand that we need to stop using traditional ML and use deep learning. And thank you, Siri, for showing the world that now's the time we can go after our dream. Now, this is all happening in the blink of an eye. At the same time, science changes. On this slide, we see the oil strike of deep learning, right? Just around that same epoch time, 2010, the top graph shows the error rate for Microsoft speech recognition. And the error rate plateaued in 2000. It was using Gaussian mixture models. It was not using deep neural nets. And then they had a breakthrough where they applied that deep neural networks to speech recognition. In the same, around the same time, look, 2010, 2011, 2012, computer vision changes. So the orange dots show deep learning approaches to AI, and the blue dots show traditional. Go ahead. Was there a question? No. I think I heard. I think I heard something. Anyway, that's all good. Yeah. Anyway, so it's changing. The blue dots show traditional CV. The orange dot shows deep learning CV. It changes the way the science is done. This is essentially all of the research technologies, all the papers around deep learning started to be, for computer vision, started to be deep learning based, right? And that's how we got here, right? 2010, now we're having a breakthrough. The market wants AI, and that's where we are. Now, if you look at where we are now, I call this the blink of an eye, and I'll show you in the next slide why this is happening crazy fast. Our entire world changed. This top 10 companies, the way our economy runs, changed from 1980 to 2010. And the check marks show all the companies that describe themselves now as AI innovation companies. NVIDIA is where it is on this chart because of the market training AI models using their GPUs. Trust me, it's not the gaming industry that's driving NVIDIA's market cap to 600 billion. It's the fact that there's warehouses of GPUs training deep learning. It's crazy, right? And this is the blink. This is a picture of human history, literally human history, right? The last 12,000 years is really as long as we've been on the planet, right? And this shows our population growth in those 12,000 years. And if you look at where computers were commercialized, computers were broadly commercialized in 1977. And then the internet came, and now AI. It's epoch now that our entire world economy has changed, right? So this is here to stay. All right, now what exactly is deep learning? I'm only going to spend like 3 minutes on this because I think it's really interesting to look at what all the noise is. Now, all of the noise is about this green circle, and I talked about it very briefly a second ago. So artificial intelligence that's been around for many, many years. And machine learning is the concept of AI learning from data. So it just looks at data and it learns stuff. But with general machine learning, you have to tell the AI what to look for and what to learn from. Deep learning is interesting because you just let it look at data and you don't select the features it learns. But in that green dot, that's what's creating the revolution. And that green dot is an approach where in the computer, we model what happens in our head, right? So of course you can create rules that seem like intelligence, like, hey, go into the room, and you can, if the room is warm, turn down the temperature, right? However, with deep learning, the way our neurons work in our head, it's a propensity that those neurons fire and they're interlinked together. So we model that, right? We model that biological inspiration into the computer using a simplified mathematical model of that biological system. That's what it is. The way it works is it's an interconnected network of those neurons, those simulated neurons. On the input layer, that 784 that you see on this slide, the 784 corresponds to 784 pixels, right? The brightness of each pixel, this is a grayscale image, the image 5, you send each pixel brightness in the network, and then on the output layer, the weights, that means the propensity to send a signal through is on each of the lines, and they simulate the firing of those neurons going through the network. And then on the output layer, it's 0 to 9. This is a neural network that predicts what number was written in these 784 pixels. The coefficients, the likeliness that these lines will trigger a signal that propagates through the network is trained, and the brightest neuron on the output of that network is the one that tells us what the answer is. And this is trained, right? These weights are forced to be tuned using a random perturbation of the weights. They're forced to be tuned to give you the right answer. So you train it with a bunch of writing, and then it'll work in the wild with human writing. That's the nugget of a basic neural network. Things got fancier than that, though, right? So, we're now using so that's a simplified. This is a general a standard feed-forward network with a couple hidden layers, but we got more and more sophisticated. We started adding attention layers and so forth. These networks got bigger, and we did more interesting things. So one of the things we did that folks know about is we launched these things on the internet, and we said, go learn, right? Many folks have heard about GPT-3. GPT is a transformer-based neural network. It's basically a model that we gave a self-supervised task to go read on the internet, learn everything you can, and then you'll be useful for new tasks, right? So you take this model, you throw it on the internet, it just reads the internet with a self-supervised task. So it's reading the internet itself, and then you can take that trained model and say, go take the SAT, or go write me some code. And it works crazy well. But at that moment, we started to experience the horror of when these models learn from the data in the world, right? And we're arriving at our greatest fear here. So everyone knows about Microsoft Tay. Microsoft Tay was an experiment by Microsoft to take one of these neural networks and let it learn from Twitter. Launch it on Twitter, let it interact with folks. And in no time, it became one of the most nasty intelligences we've seen, right? It was saying racist stuff, it was saying egregious stuff, and Microsoft had to apologize and take it down, as if Microsoft, gave it that knowledge. It actually learned from what people were saying on Twitter. Sounds like a bad idea, but they did it. And then the horror scaled with intelligence, right? This is essentially that GPT-3. This is a large model, 175 billion parameters, that was launched on the internet. And that's a simplification. Of course, the internet was somewhat, prepared for this model to learn. But based on its learning, it also learned a lot of the nastiest things that we have as humans, right? This is a quote that the model wrote from scratch. That's actually, it's so egregious I won't even read it, and I'm like running low on time. So we have to face this fear, right? And I equate this fear with, it's a lot like when we train our children. Like if you let your children into the world unsupervised, they're gonna go off and they're gonna learn the terrible things, right? Perhaps. And so there's this anxiety that we have to let these models, let our kids, they learn from data, they learn from experiences into the world, and we'll have to do that. At some point, you have to let these models go, and you have to trust the models. We have to stop having, in order to innovate, we're gonna have to take some of these risks and trust. But what do we do with our kids? We don't just let them in the world willy-nilly, we supervise them, right? We mentor them to become the best humans that they can be. And now I'll just briefly talk a little bit about where we're going. Sorry, my kid's like coming in, he's so crazy. We've seen the market go from rules-based approaches to deep learning, and we've experienced what's like. I recently, one of the first companies I created is a company called Clink, and we were able to take a completely new approach to conversational AI, and we were able to achieve monthly more and more interactions, users coming back, when we completely threw out rules-based approach, and it was wildly successful. Now I'm working on zero-shot, one-shot, few-shot learning. I think that this has the potential to really change the way we experience AI. You don't have to train it. One of the hardest things is training these models. So how do we get the models to be so smart that they can solve new problems without training? Video, I'll share these links after, of experiencing a zero-shot approach to conversational AI through a product I call Zero Shot Bot. It's actually available. Anybody could try it. It's online. And this was built on a technology stack that I've been creating with some super smart colleagues called Joseki. And it's a completely different approach to AI and an ecosystem and tooling for bleeding edge AI. It's free. There's concrete new technology ideas. This is an idea that a paper we wrote around scaling personalized intelligence with this kind of technology. Amazing group of people. Check out joseki.org if you want to learn more. But this is where the future, in my perspective. So thank you. I know I'm like right on time. right at the cusp of time, so I'm happy to look at some of the QAs real quick. 30 seconds over. So I'll spend 1 minute. Oh, you're stuck on the slide. The slides aren't moving. Oh no. Are you guys, did it? All right. Well, thank you all for coming, and until next time.